So first, thank you for being here. It's the last day, it's noon, and you want to talk about NSX automation, so that's great. So I'm taking a few minutes first, just as people are joining, to understand a few things. Can we do a show of hands for everyone who is running NSX? Who is running NSX here? Just so that, oh, okay, so people, knowledgeable people. Who is doing zero automation, everything from UI, click, click? Okay. Who is doing 100% automation? Everything goes to a pipeline and Terraform or your script. So everything from automation. Okay, so in between. Maybe one last question. Who is using ARIA automation? ARIA automation people here? Okay, cool. Who is using Terraform? Few Terraform people. Ansible? Okay. Direct API? Okay, both. Anything I've not quoted? PowerCLI? PowerShell? Ah, yeah, we have PowerShell. Okay, okay, cool. So, well, let's start. In this session, the idea is to start from zero on automation, and we're going to go from the very beginning to more advanced use cases, to have that really built around demos. So a lot of it will be us showing you, and we try to make API visual as much as possible, and to answer your questions. So we have a good amount of people, but not that many, so don't hesitate to ask questions. And maybe just to do the introduction, so my name is Thomas Vigneron, and I am the product manager in charge of NSX, in charge of multi-tenancy, NSX multi-tenancy, in charge of the VPC constructs that you might have heard about in the different sessions, and in charge of the automation and API. And I work with Antoine, who is our technical product manager on automation, containers, and so who works on those parts. And first, as a disclaimer for people who might have missed it, we are French. We are people who have a reputation of being bad with H and R. So if anything is unclear, please make us repeat, and we are sorry in advance. Yeah, we will try to be as clear as possible, but please, if there's anything unclear, make us repeat. So maybe, yeah, we're almost at time. Let's start. So in this, we're going to cover different features from NSX. Some of them may contain roadmap. We'll mention it when that's the case. And roadmap can change. Well, I think you've seen these slides multiple times. So now, as I say, we're going to start from the very beginning. Like you never used the API at all. You've done everything from UI. But de facto, if you've done it from UI, our UI calls the API. So you've done it from API without knowing it. But two different means of automating NSX. And we picked some of them. We had to make some choices because there are many. So we're not covering them all. And so if you want to talk about another one, please let's bring that. But otherwise, we're going to go over those because they are the most common. And so just to do the introduction, NSX can do plenty of things, which are not the topic of this session, from federation, VVPN, distributed firewall. And everything is API first. Everything in NSX comes in the API before being in the UI. A few things are even only in the API because, well, UI resources are not always available when you want to ship something. And so from time to time, when you're a PM, you're like, oh, maybe I could make that available from API first. That might help some people. So now we are going to talk about how to consume that. But keep that in mind in that NSX, there's not a feature where we will tell you, oh, you can do it from UI, but there's no way of automating it. Because the model is really, first we do the API, the UI consumes this API, and then people can consume it. And then we do some tooling on top. So now the goal of NSX is to deploy full environments from one single point of configuration. And then you can do whatever you want with that. You can do security, you can do networking, you can do everything. And the goal here is to show how we can do that in a easier, more repeatable manner with the API consumption. And as people are joining, we were very at the very introduction. So which is, in NSX, every feature is exposed through API. We also have a large ecosystem Part of it is managed by VMware, like Area Automation, vCloud Director, or even our Terraform provider, our Ansible modules, they are done by VMware. And part of it is done by some third party, like people who want to integrate with NSX. It's a free API, it's available. And also, the last thing, the new thing which comes, is that in addition to an API, we now have a multi-tenancy framework to split the consumption of NSX with projects and VPCs, which allows users to go directly to the API and still to have some strong multi-tenancy there. So we're going to touch a word on that. So starting with the API, as I said, starting from the ground and then going up, everything is documented through the API documentation, which you can find directly in the UI of the product, or you can find from developer.vmware.com. And the way it is documented is that NSX follows something called OpenAPI, which gives it a spec, and from this spec, we can generate a number of things. We can generate SDKs, and we generate the documentation. So documentation follows the spec, so which means that documentation is correct. It might, to be frank, what's written in terms of description might not be clear on absolutely all the calls. It might, there might be some things which are clearer than others, but the documentation covers completely the API, and we try to review it to make it clear for people. So now, how do I consume the API? And that's a question I got. Same way you consume the UI, same API, same URL, and you go against your UI, you go against your API from the same URL, and technically in the background, two things are happening. One is either you're going to the cluster VIP of the cluster, so you have the three managers, and one of them is the one that you reach and that you consume from the API consumption. And if this manager has an issue, another one will take over, possibility one. Or possibility two, you go against the three managers. All three of them, they can work. And we see that for environments with heavy automation, like if you're doing Kubernetes, if you're doing a lot of churn of creation, deletion of things, like in the past, people with OpenStack typically did that. You can go through the three managers, and they will work in parallel. And that is an interesting fact on just the framework. The NSX manager tries to help people doing the API without breaking the system. So it has an API rate limit per manager, and in this manager, it will say, if I have more than 100 requests that I'm doing, if I'm doing more than 100 things in parallel, I'll tell you to wait until I finished and I have some new slots available. So that's per manager. And so it works, and because some of your requests can be very simple, like create a logical switch, do a get on a logical switch. Some of them might take more time from the manager. Let's say you have an environment which is very used, and so you have an edge node which is doing a lot of things, and you are querying this edge node to gain some statistics or that type of things. It takes a bit of time for the manager to send the request to the edge node, get the stats, give them to you. And so during that time, this session will be used. And so until one of the 100 session is free, it will tell you to stop and to defer the next calls. And what is good is all the automations which are done on top of NSX by VMware and most of the time by third party, they know that, they take that into account. They know they'll retry later. And also another thing which I want to mention to people is you have some per client API rate limit in NSX, and you have a default. NSX by default tries to think that maybe you want to be fair among your client, among people who consume the NSX manager. And what is a client for NSX? That's an NSX user. That's not an IP. So it means that if when you configure your different product consuming the API, for instance, let's say you're not doing any automation at all, but you're configuring VROps, area operation, area networking, other monitoring product, and you have a number of those, and you are all configuring them with admin. For NSX, that's one client. So all those products, they are consuming NSX as one client, and for fairness, by default, this client is limited in what it does. And so here you can have two solutions. You can say, well, I don't care about fairness. And if at some point product 1 doesn't manage to get its API calls because product 2 is sending too many, I can remove those. That's possible. Or you can use some different clients for those. So just keep that in mind. When you enter NSX as a service account into another product, this service account is the client for NSX. And by default, NSX has those API rate limits, so a number of requests and a number of connections per client. And those can be changed, those can be tweaked. But if you are writing code against NSX, before changing the limits, we recommend heavily to people so that they will pick up the code that we send back to make it manage them, because the goal is to, one, protect the system, and two, offer fairness. And on that, Antoine, I'll leave it to you.
Okay, so let's start about talking about one way to automate NSX, which is policy API. So policy API is something which is intent-based, declarative, and hierarchical. So what does it mean actually when we say declarative? Let's assume that you want to, let's say, create a security rule in a security policy, and that this security policy is going to consume some security groups, okay? With an imperative API, or basically with our former API, you will have to do several calls in the correct order. So you will have to create first, to do a post API call to create your security group, get the ID that is going to be generated, and then use this ID later on to create security rules with another API call, okay? So it means that you have to manage by yourself the correct order of creation or deletion of all these resources, okay? And you also have to deal with IDs, which is generated by the system. So it means that you can't really take your configuration and put it on another NSX manager because the ID will not be the same, okay? So with the declarative API, it's quite different. What we will do is that we will just define what is the final state, the intent, what we want at the end of the day, okay? So for that, we will be able to do a single API call, basically a patch API call against NSX with a kind of big JSON file, let's say, that will describe exactly the resources that you want to have at the end. Again, you will not explain how to do it. You will just define what you want. Okay, make sense? And behind the scene, the NSX platform itself is going to translate, I would say, what you want to do in multiple imperative API calls, okay? So it's really different. If you know Terraform, for example, you know it's a bit similar, okay? You just define your final state. So we don't support any post method on the policy API, okay? Because the post methods are supposed to generate some system-generated IDs. So in this case, we will just support put and patch if you want to create or update some objects. Obviously, we have the get, but we have pretty cool stuff on the get. You know, you can filter. We support some regex if you want to get some specific information about what we have in NSX. And we have the delete, obviously. But if you want to delete something, you can also do it with a patch. There is a specific field, like mark it for delete, that you can use to delete something. We have this API model, which is a tree that begins with /infra, I would say. And then you have a kind of parent to children relationship. So you will have your tier 0, your tier 1s, and inside the tier 0s, for example, if you want to declare the BGP configuration, it will be a child of one specific tier 0, okay? So it means that it's really easy to find the resource path, as you can see at the bottom of the slide. If you want to update a specific, I don't know, BGP settings in a specific tier 0, you can easily find the right path for that, okay? So let's go through a quick demo. I think it will make sense for you. So let's really start from scratch. So at the left, I've got my IDE. We don't see very well, I think. And on the right, we see just NSX without any specific configuration, actually. So what I'm going to do is I'm going to use a patch to push my intent to my NSX. So I'm going to use, NSX, which is my API endpoint, I would say, and /policy API v1 infra as the URI, I would say. I set the authentication, the authorization as a basic one. We support multiple kind of authentication. And obviously, I'm going to push some JSON, so I set the content type as application/JSON. So with hierarchical API, we are going to start at the very beginning of the tree, okay, at /infra. So I begin by specifying infra, with the ID by default is infra, and inside the root, I would say, of the tree, I will set one of multiple childrens. So in this specific example, I'm going to create a tier 1, okay? So I set the resource type as a child tier 1, and then I will specify what I want to define in my tier 1. Again, I just have to say that this is going to be a tier 1. Then I can set the ID. So this is the first difference with an imperative API, okay? I set by myself the ID. I don't have to set the display name, for example, it's going to be the ID by default. And that's it, really easy. If I just send this API call, dispatch, you see that this tier 1 has been created, okay? So very simple, from scratch, this tier 1 has been created. Now let's update, I would say, this configuration, and I would like to connect this tier 1 to a specific tier 0, okay? What I'm going to do is just modify, I would say, this JSON by adding a specific tier 0 path. And you see that this path is easy to guess, actually. It's /infra/tier 0s and the ID of my tier 0s, which is, again, by default, the same as the display name, okay? I just send dispatch call again, and you see that now my tier 0 is connected to my tier 1. Now I can easily add other tier 1s. I just copy and paste that, at the end of the day, it's just a text file. I just change the ID, and I can create easily a new tier 1. Okay, I refresh, now I've got 2 tier 1s. Let's do something else. Let's create some segments that are going to be connected to the tier 1s. So my resource type this time will be child segment, okay? And then I will define my segment with some fields. So I will say that the resource type is segment. And then I will be able to set again my ID. Okay, again, I set my ID by myself. It means that I can refer to other IDs in this file. So let's call it explore S1A. And I will use the connectivity path to say that I want this segment to be connected to this specific tier 1. So again, the path is easy to guess, /infra/tier 1s, and the ID that I've set by myself earlier in this file, okay? I will also set some, the default gateway that is going to be used for this segment. And that's it. So I will have my segments connected to a tier 1, connected to a tier 0, okay? I just click send request to send my API call. And I've got a 200 return code that's saying that basically the API call is successful. And then you see that I've got one segment with the correct subnet that has been configured. And this guy is connected to my tier 1. Again, I can easily create a new segment by just copy and paste and changing some IDs. Very easy, okay? So I've got my 2 subnets. And if I look at my topology, I was able to create from scratch, several tier 1s and several segments, just by updating, I would say, my /infra tree. What is cool as well is that you can use this file as a template, I would say. So if you want to define some variables, I don't know, the name of some tier 1s or the segment, for example, in this case, I will just use delete because I want to to be able to say I want to delete or to not delete, so to create my resource, I will use, mark it for delete and use my variable to change basically the value to true or false if I want to create or delete my resource. I can easily copy and paste that. And that's it. So now I can just change the value of my delete variable and it will create or delete everything. So you can see now that I don't have my tier 1s and my segments anymore. No segments and no tier 1. And finally, which is the stuff that is pretty cool as well, is that it's just a text file. So basically, I can set that file as a baseline, I would say, to make it a template. And then I can rely on any Git stuff. If I do any change on this configuration file, I can use any Git, diff stuff to see the differences and use some. I mean, if you are using some CI/CD pipeline, it can be very, very useful. Make sense?
So now let's talk about something which is brand new, which is the multi-tenancy and the VPC. It's brand new, but available. It's not a vision or anything. It got released in 4. So projects that we're going to talk about got released in 4.1.0, and VPC got released in 4.1.1. And so what are those constructs and why are they interesting? API allows us to do very powerful things here, just like user from UI. But NSX is a very powerful tool. Like you can, for instance, push a firewall rule to all your VMs in your environment. So now, let's say someone wants to automate NSX. Someone wants to use Terraform, someone wants to use scripting. And if you give him access to NSX directly, either as an admin or admin of a specific part of a product, like security admin, networking admin, they are able to configure all the objects inside this area. And so that you don't want someone to make a mistake and to touch your firewall rules. Now we can slice the system. We can create projects and assign them to lines of business, to different teams, and to say, you are the project admin of this project, which means that you will be able to create your own objects, your own tier 1s, your own segments. You will be able to create firewall rules on your own VMs, but you will not touch the VM of the neighbors or the VMs which are not inside any project. So the way it works is the enterprise admin creates a project, allocates a tier 0, allocates an edge cluster or tier 0 VRF, and then, if he wants, allocate a quota of objects to the project. Like in this project, you'll be able to create 10 tier 1s, but not more, and assign this to the user. And then this user is able to create the tier 1s, the segment, the firewalling, everything we've seen before, but within the limits of this project. And inside this project, we have a second level of tenancy, which is called the VPC. And the VPC, and I'm going to talk about it right now, is inside the project. So here, I have my project going to my tier 0. Inside the project, our idea is that we have a second level of users who are more DevOps persona, who are more app owners persona, and they are not networking or security admin. They are not NSX admins. So they know how to create networking and security because they've done it on the public cloud. They've done it on some cloud management platform. So they have some basis. They are able to create some rules, some security groups, some networks, but they don't want to handle the router and the advertisement. And so we can have this persona be the VPC admin and configure subnets, connect VM, do some firewall rules, do some NAT in order to have some elastic IPs, all that without touching the NSX construct, so without touching the tier 1s, the edge cluster, so having an abstraction restricted to an application. And so really the idea here is project can be a line of business, a team, and VPC can be an application which is deployed. Everything inside the VPC is routed by the VPC router. And so what's interesting, and we're going to do the demo on project because I've been a many session on VPC. What's interesting is in project, as we'll see, your APIs are the same. They are the APIs from NSX, simply in the project context. So here I upgraded to 4.1.1 or 4.1.0. We can do that. And here you see I can create projects. I'm the admin. I create a project for Alice. and I create a project for Bob, and I allocate it to my user. Alice will be managing Alice's project, and Bob will be managing Bob's project. I am the admin, I manage everything, so I see everything. But now, it's not interesting if I do multi-tenancy as the admin. I'm a bit too powerful. So you see Bob, first, he doesn't have all the options. He's not able to uninstall the system, to upgrade it, or to configure his tier 0, because as mentioned, the tier 0 is outside connectivity, so defined by the admin. When we create the project, we create one group which represents the project so that the admin can create some rules which says project 1 to project 2 can talk to each other. Now, here, what we see is the API. And this API is exactly the same model than NSX with some additional information. You can see project as a folder, as like a place where you will put the object from NSX. And so in the path, you have the project path. And now Bob will push some security policy. This call, this payload, so here we've done it around firewalling, but it's exactly the same as the payload that Antoine presented. It's exactly the same model. You could take this payload and push it typically under /infra without any project, and it would be the same. So now Bob can create its firewall rules, which will apply only to the VMs connected inside the project. So if you want to do firewall delegation, you can do that now. It won't touch any VMs which are not connected to networks inside this project. Alice, on her side, she doesn't see any of those rules. Those are the objects from Bob. She's not able to do a get on them. She's not able to edit them. The administrator can see all the rules. The administrator has a view so that he can see everything, and he can even push rules on top of that if you want to have some common rules applied to everyone. Now, we are Alice, and we want to do something against the project of Bob. Not possible. Same call, which was working for Bob, but Alice doesn't have the RBAC in order to touch Bob's object. Same thing, Bob cannot touch Alice's project, so that goes both ways. But Alice can manage her own project. Just for information, a user can have access to multiple projects, and also a user can have some more granular RBAC inside the project. Maybe Alice is just a security admin of this project and not a full admin. So same thing for the get. So you can get the information, you can reuse them. As mentioned, the goal of the payload is that it's as close to possible as the NSX payload. So the path is different to indicate the context, but the payload is the same. And the admin can see everything. That one is important. If you are enterprise admin, not only you have your own objects, which were the objects you've been configuring so far, there's no backward compatibility, breaking, or anything, but in addition to that, you can configure the objects inside the different projects.
Thanks. So if you don't want to play directly with APIs, there is something else which is pretty cool, which is Terraform. So I guess that you all know what is Terraform, which is very popular, for infrastructure as code management, I would say. But we have a provider for NSX, which is very popular as well. So you can see that we've got millions, almost 2 million of download, which is not so bad. This is very simple to use, and we will see that in a demo in a minute. So you can use it on your regular NSX setup, what we've called LM, local manager. But if you use Federation or VMC, you can also use the exact same provider. Okay, so it's something that it's good to know. Something which is cool, I guess, is that the source code is on the public VMware repo. Okay, so you have access to the code. If you want to create any issues, to contribute, to create some pull request, is definitely something that you can do. From a support model, I think that it's quite interesting. So it means that if you rely only on the open source version, you can use the very, very, very latest version, test new features and so on, okay? And again, create some pull requests, try to contribute. But what we do is that each, quarter or something like that, at a regular interval, I would say, we take one version, and so we put it on the HashiCorp registry and on the VMware website. Okay, so if you use this official version, I would say, you are fully supported by VMware. Okay, so you can open, file an issue if you have any bug, in the provider, this kind of stuff. Okay, so it's, again, it looks like something which is open source, but it's fully supported by VMware. I'm going to be quick on this one because we are going to see that in the demo, but basically you've got three main concepts in Terraform. So there is the provider section where you set some information about the API endpoint, basically, the FQDN, the credentials, and so on. And then you've got data sources. It's used to fetch or collect, some information from the infrastructure, but it will not change anything. And there is some resources. So resources, it means that Terraform will manage the life cycle of the resource. It will create, update, and delete the resource, okay? And the resource can use data source if need, as you can see in this example. So let's go through a quick demo. So you see on the top of my file, sorry, I've got the ID, same story on the left, and on the right, you see that I've got just some tier 0, some segments, and tier 1. I don't have any groups so far, just the default groups, and I don't have any firewall rules. Okay, so very basic setup. So on the left, you see that, so on the top, I've got just few lines of code saying that I want to use my NSX provider. Then I set some information about the provider itself, so the IP of my NSX and some credentials. Then I will use some data source for the edge cluster and overlay, for example, because it's something that I will use later on. I can use this resource, an NSX policy tier 0 gateway, for example, to create a tier 0. I've got another kind of resource to create a tier 1. So I just set the kind of resource and the name of the tier 1. And I can refer to the edge cluster thanks to the data source that I used before. I can also refer to another resource. So for example, my tier 1, I want my tier 1 to be connected to my tier 0, and so I will use the NSX tier 0 stuff as a reference to connect it to my tier 0. So in this case, I've got two tier 1s connected to my tier 0. Then I have two segments, and each segment is going to be connected to its tier 0, I would say, with the transport zone, again, that it's coming from a transport zone. And I will define some subnets and some other configuration stuff, okay? It's quite the same kind of configuration that we have done with the policy API before. Then I can create some groups, like all the VMs, and a specific group for DB, for app, and for web. Then I will create some security rules. And so I will have to use some services. So again, I use my data source to fetch some information about the services. And then I can create security policies in the specific category, let's say the application category, with some rules, that are going to use the policies, again, the services fetched before. And so I create several rules, as you can see, in several categories, okay? So now if I want to play with this file, it's quite easy, actually. I just have to do a Terraform init to fetch the provider, from the HashiCorp registry. So it's very easy to do. And what is pretty cool with Terraform, it's the plan feature. So you can do a Terraform plan, and it's going to connect to the infrastructure and look at your TF file and make the comparison, and it will show you which resources are going to be created or updated or deleted on the infrastructure. And if you agree with the plan, you can just do a Terraform apply and configure the changes will be made. Okay, so you see 12 resources have been added, 0 change and 0 destroyed. So on the right, you see that now we have a tier 0 that have been created. We've got 2 tier 1s connected to the tier 0s. We've got 2 segments, each connected to the right tier 1. Then if we look at the network topology, you see what we have created with Terraform. Again, tier 0, 2 tier 1s, and some segments. We also have some groups that have been created, so all VMs, web, DB app, and a security rules, or some security rules in the application category, as you can see. and in the infrastructure category. Okay? Terraform is also idempotent. It means that you can run it multiple times. It will not, duplicate the resources. Okay, so if you just do a Terraform plan or apply again, it will just do nothing basically. So it's interesting because it means that you can run it at a regular time if you want to do it. Okay. Let's assume that you want to do any change. So I've just changed the action of a specific rule to reject. So I can do a Terraform plan, and it will understand that that one action is going to be changed. Okay. So you can really plan your change before applying them on the infrastructure. Again, if you agree with the plan, you just do a Terraform apply, and it's going to be pushed on the infrastructure. Same story, if you want to destroy everything that you have automated with Terraform, you just do a Terraform destroy, and everything managed by Terraform will be destroyed. Make sense? We are not so bad on timing, it's cool. So you say yes, because you don't want to delete without confirmation, and all the resources are deleted. Okay? So now let's talk about another way to automate NSX, which is area automation. So I'm going to be very, very fast on area automation because it could be, a huge topic, okay? But I just want to highlight, I would say, what we can do from an NSX perspective within area automation. So basically, area automation, very, very quickly, it's our enterprise-grade cloud management platform. So you can use it to deploy, create some blueprints that are going to deploy some VMs, and so forth, and so on and so forth. So what is cool, if I really focus on NSX, is that you will have this kind of Canva and design. So basically, on the left, you've got some objects that you can consume with area automation. And so you can just drag and drop, these objects in the Canva, and create your own topology, basically, okay? So you can do that with security groups, networks. So you can consume existing objects, like connect VM to existing NSXT segments, for example, or you can create them on demand. And we will see which kind of network you can create. Okay. You can also use it for day 2 operations. So if you want later on to change the membership of groups, for example, it's something that it's feasible with area automation as well. And if the native integration of NSX is not enough, there is also some extensibility option that you can leverage. So you can use VRO, you can use ABX, to use basically direct API call directly from area automation if you want to do so. And what is pretty cool as well is that you can, with area automation, consume Terraform. So what we have seen just before, you can basically consume it directly with area automation as well. So we support multiple kind of networks, but let's say private, which is just a DHCP server, but not connected to any tier 1, just isolated. Outbound, that is going to create a source NAT. It means that all the outbound traffic will be allowed, and we will source that, the traffic going outbound. Or routed, which is it's very similar, but basically we don't create the NAT rule, okay? It's going to be routed. So I go through a very quick demo. So I will build a Canva, I would say, from scratch. So I just give it a name, and I will do it in a specific project. So basically, you see on the left, I've got all my area automation resources that I can manage. So I will focus on the NSX one, and I can just drag and drop, a network in my Canva. Then I can edit some settings on the right. So I will give it a name and set the type as routed. I can do that for two other segments. So I will do that for the app segment and for the DB segment. Okay, so now I've got 3 segments. I want these segments to be routed with a tier 1, so I will just drag and drop a gateway as well, and just connect like that my segments to my gateway. Okay, so very easy. I can give it a name as well, like tier 1. Okay, so for the network, that's it. And I can also manage some security stuff like security groups. So I can again drag and drop my security group, give it a name like explore security something. Change that to a new because I want area automation to create these security groups, I would say. And so I will set some settings like the destination. So it can be inbound or outbound. The protocol like TCP, the port that is going to be HTTP or AT. I will give it a name like hello HTTP. And the source as any, okay? So very simple again. If something is missing, you see that there is a kind of exclamation mark or red box, so it will prevent you from doing any mistake, and that's it, okay? So you have defined this blueprint, and so you can now use it. You can put it in the service catalog, to make it available to end users. And basically, if I just deploy this blueprint, so in real life it's more something like 5 minutes, okay? Again, all these objects or resources have been created. So I've got my tier 1s connected to my tier 0. I've got multiple segments with the subnets that has been assigned by the IPAM of area automation, so you don't have to manage your IPs. So you can see here the subnets and the segment that have been created. You can see also that there is a group explore security, something that has been created. So right now there is no members, I would say, in this group, but I can add members by myself. I can rely on tags, or I can ask to area automation to also consume this group and put some VMs on that, for example. And then I've got my security rule that have been created. Does it make sense? Yeah?
So now, to conclude, a few things. One is we didn't cover all the automations. And there are other tools, and we acknowledge that. So we have some content on that, and we are happy to discuss about that. We've made some choices. We try to put some examples together, and we have the API documentation. And since you stayed until the end, a few additional tips. As mentioned at the beginning, our UI is just a layer consuming the API. And so if you want to know how to automate an object, there's two ways to do it. Create it from the UI, and since it's declarative, you do a get on this object, and you'll find the information. But you can also, in many cases, there are some corner cases where UI hides you a little what it does, but in almost all of the cases, you check what your UI sends. Like when people tell me, hey, Thomas, how do I create a tier 1 with blah? I go to my UI, I create the tier 1, and I check, and when I send it, my UI is doing patch infra exactly as Antoine with the different fields. And there I can appear like a clever person to tell me, hey, here is the API call. So you're just looking at what the UI does helps a lot in choosing in understanding what the API does, because the UI is just in some way another manner to help you automate, but with click. And yeah, so that was the tip for people. Personally, I find that extremely useful when I'm writing automation. And don't hesitate to reach out if you have any questions or requests. Don't hesitate on all those GitHub that we gave to submit queries. And as mentioned, and that's true for Ansible too, it's like Terraform. Those are supported, meaning we have engineers from the NSBU who are working on those modules. We put them open source on a GitHub because we want community to be able to participate, ask questions. But for the ones which are pushed to HashiCorp and which are pushed to NSX download page, they are NSX deliverables. So they are supported as well as any NSX deliverable like that. And so it means that tomorrow, if the community moves to something else and doesn't do Terraform anymore, VMware engineers will continue to support those modules and to extend them, for instance. Okay, and that's we have sometimes for questions or feedbacks. Yeah. Can you use the mic? So sorry to make you walk.
It's for the recording. Thank you.
So I saw in that ARIA automation demo, when it created object, it created like a lot of long string of object name or ID. How that determine and why is that?
ARIA adds some additional metadata, let's say, to the names based on the object that it creates. The display name is a free field in NSX. Your object has a path, and the path has an ID. And then there is the display name, and the display name is a free field. And so ARIA, and my view is that it's for repeatability because it recreates the same object multiple times with all the blueprints, add some metadata related to the deployment so that they don't all come with the same name because Antoine called it tier 1. But let's say he deploys 20 times this blueprint, you would have in NSX 20 times tier 1. And so then you can go check what is the real ID of this because it's not the same one. But ARIA tries to make it nicer by putting some ID inside that. It takes repeatability into account. When we did the demo, we just created the payload, but as mentioned, we can template it, and so we could iterate or put something. So that's what ARIA is doing, that's why the name.
And those are probably random generated, those additions?
I think they are based on the blueprint. I can check, they are based on the deployment ID, I think.
Okay, thank you.
Same thing to follow up on that. I think there's also the custom naming templates for resources. And so while, yeah, it has a repeatability and you want to have like a serial number so that, you know, it's something new and different each time, you can probably minimize on that cruft by actually having the custom naming template for that resource. So that's probably going to go back and investigate that.
Yeah.
Next question for me, I just came from the Protecting vCenter from ransomware. So my question is what's your recommendations for securing logins and authentications against this API? And is there any like WAF recipes that you'd recommend?
That's a good question. So there are multiple ways. So first, you have the different authentication that you are using. So one is you can use very basic authentication, but you could also use some other authentications which might be more secure. For NSX Plus, for instance, we'll integrate with the cloud service platform to have a common authentication for VMware product. But for NSX itself, you have things. For instance, if you're using a tool like VRA to automate or a tool like Terraform to automate, instead of using basic authentication, you can have something which is certificate-based. NSX allows you to generate a certificate, which is called principal identity, and then to do your automation authenticating at this certificate. And NSX will also assign the object to the user if you're using certificate like that. That allows to protect them from deletion by third party. And so that will allow to identify exactly your source of automation. So that's what I'm thinking of right off the bat. On defining which authentication, you can disable basic authentication, for instance, and then of course there's restricting who can access your NSX manager. We go with the assumption that your NSX manager is inside your data center, and that it's not something which is open on the internet or things like that. Any other questions, feedbacks? Like, please.
Is it possible for NSX to issue an API call for automation to something like a third-party DNS source for, like we have DHCP set up on the segments, and every time NSX gives out a DHCP address, is it able to orchestrate any kind of automation?
Today, no, but I'm interested to talk to you because for the VPC piece, we allocate the IPs to the VM, and it's true that we are exactly looking at that. That like we are allocating the IP. We don't want to bring our own DNS because you already have one, and you probably don't want us to bring yet another DNS. But we are interested to see how the goal of the HCP is to make it that someone doesn't have to manage the IP directly. So when they create a subnet, they say, hey, I want a subnet. I can pick the IP if I want, but the idea is they can say, I want 64 IPs, and NSX IPAM takes care of everything for you. And it would be great that it could enter it in the DNS. So I'm pleased to have follow-up discussions because we are starting to think of something like to go update DNS.
Okay.
That's a road. But this one is future. It's not there today.
Okay.
But that would be a good discussion.
All right. Thank you.
So I'm not sure this ODA's would be able to do this when they boot up. They boot up, or well, the DHCP. So that's a question. I wonder if the DHCP server at NSX
Yes.
could do dynamic DNS updates to the DNS. So
That-
you allow
That's what we're thinking of, but it's not the case today. So that's why I'm saying that I think that could be an interesting way to solve that issue. So if we can do dynamic DNS and we have something generic enough, like the dynamic DNS is an RFC, so it should work typically with infoblogs and the others, that would allow us to update your DNS. And then when we were brainstorming about how to solve that, to really have the full-fledged VPC with the DNS, we thought customers, they have their DNS, they don't want us to create another DNS. So now can we just update their DNS with dynamic DNS? So yeah, I'm happy to have follow-up discussion on that topic with people interested, because that's something we are considering for the future. Any other question on automation? Was that helpful? Yes. Okay. Thank you.